Hello, my name is Mike Winslow. I'm the Program Manager for the Otter Creek Basin Clean Water Service Provider. I'm here today to provide an introduction to the Lake Champlain Total Maximum Daily Load, or TMDL. This presentation is meant for other clean water service providers, Basin Water Quality Council members around the region, and anyone else that might be interested in Lake Champlain pollution policy. The Total Maximum Daily Load, or TMDL, is a program established by the Clean Water Act of 1972, and it's required for all impaired waters around the country. It essentially sets a pollution budget for each of the water bodies. The pollution budget defines the maximum level of the pollutant, the total load, that can be discharged to a water body and still allow the water body to meet water quality standards. For Lake Champlain, that particular pollutant is phosphorus, and so the TMDL for Lake Champlain is built around phosphorus, and thus the Clean Water Service Provider program is built around phosphorus. The total allowed load is broken into four components: a waste load allocation, a load allocation, an allocation for future growth, and a margin of safety. For the purposes of this presentation and for the purposes of the Clean Water Service Providers, we're going to set aside those allocations for future growths and margins of safety. They're built into the process, but they don't really affect how our procedures work. What I will focus on is the waste load allocation and the load allocation. The waste load allocation is based on permitted discharges. The obvious permitted discharges are wastewater treatment facilities, but this also includes individual stormwater permits, municipal separate stormwater systems, the municipal roads general permit, the 3-acre rule. All these are built into the waste load allocation. Even the required agricultural practices and required forestry practices, those go into the waste load allocation. Everything that's left over is the load allocation. The load allocation includes what would naturally be discharged to the system and any sources of non-point source pollution. The non-point source pollution is the only thing that the Clean Water Service Providers are allowed to deal with. So the whole work of the Clean Water Service Provider program has to take place within that load allocation portion of the TMDL. Some examples of projects that QISPs can fund to address the load allocation include restoration of vegetation in riparian or lakeshore zones. These projects tend to be relatively low cost and high benefit with limited design needs. We can fund stream restorations, including berm removals or dam removals. These projects tend to have a lot more extensive design needs and tend to be much higher cost. Benefits can be very large or small depending on the project. We can fund erosion mitigation on private roads and on some forest roads if the forest roads are not covered by the acceptable management practices. These projects are intermediate in their cost benefit. Or we can fund stormwater mitigation for projects that are either too small to require permits or where the treatment provided by is in excess of the permit requirements. These projects tend to be expensive relative to the benefits gained. The total maximum daily load is what the water body can absorb and still meet water quality standards. Water quality standards are established by the states and approved by EPA to ensure that the water body can meet all of its designated uses. The designated uses for Lake Champlain are aquatic biota, wildlife and aquatic habitat, aesthetics, its use as a public water supply with proper treatment, irrigation of crops and other agricultural uses, swimming and other primary contact recreation, boating, fishing, and other recreational uses. Now, the ones that are relevant for phosphorus are aesthetics and swimming and other primary contact recreation. Phosphorus is thought to impede those two of the designated uses. It does not necessarily have an effect on the other designated uses. Phosphorus is a fertilizer. It promotes plant and algae growth. When the plants growing are crops or grasses on land, additional growth is desirable. When the growth is algae in recreational waters, the result is less desirable. In the words of the TMDL, the reason that phosphorus is considered the pollutant of concern is because it is causing or contributing to excessive algal biomass in the lake. The TMDL's own language recognizes that the role of nitrogen in the lake restoration is still uncertain, which is why they focused on phosphorus rather than nitrogen. And they suggest that there was clear evidence from case histories and whole ecosystem experiments that phosphorus reduction can successfully control algal growth. So to dive more deeply into why phosphorus is the pollutant of concern would require a completely different presentation. If you're interested in that presentation, leave comments in the comment section and I could do that perhaps at a future time. With that in mind, it's important to remember that phosphorus is a model of pollution. It's not inherently a pollutant itself. Phosphorus doesn't cause illness, it doesn't cause sickness, it doesn't cause cancer, but it's thought to contribute to algae blooms. It's the algae blooms that we consider problems. So phosphorus as a model is a simplification of a complex ecological system in order to focus on an important variable that is more controllable than the direct algae growth. The phosphorus water quality standards for Lake Champlain were initially established in 1991. They are quantitative and numeric. That means that you can go out into the lake, measure the water quality there, and see if it is meeting the standards, and depending on your frequency of measurement and spatial array measurement of measurements, you can see if there are changes in the water quality over time. The initial standards were agreed to by New York, Vermont, and Quebec, the three governments surrounding the lake. There are separate standards for each of the 13 lake segments. 5 of those segments are contained entirely in Vermont. 1 segment is shared between Vermont and Quebec, that's Missisquoi Bay. 1 segment is found entirely in New York, that's Cumberland Bay, and then 6 segments are shared between Vermont and New York. Because there are separate standards for each of the Lake Champlain segments, EPA considers each segment to have its own TMDL. They refer to the Lake Champlain TMDLs plural. But the segments do interact with one another regarding to loading, and so that the TMDL is often seen as one thing. The standards for the 13 lake segments range from 10 micrograms per liter to 54 micrograms per liter. This map shows the different lake segments for Lake Champlain. In the far north, in the fuchsia, on the border of Vermont and Quebec, you have Missisquoi Bay. To the left of that, as you're facing the screen, is the brown segment. That's the Isle La Motte segment, shared between Vermont and New York. To the right of that is the northeast arm, with St. Albans Bay being a little purple dot in it. Cumberland Bay is the brown spot around Plattsburgh. That's the only segment entirely within New York. The main lake, which comprises the majority of the water of the lake, is the lilac in the center of the screen. Mallett's Bay sits between the main lake and the inland sea in the sort of orangey brown. Burlington Bay is in green in the near city of Burlington, with Shelburne Bay just south of it. The Otter Creek segment, where our QUISP does its work, is in this yellowish color. Then below the Otter Creek segment is the Port Henry segment. The South Lake A segment is the lowest one that you see, and then the South Lake B segment is off the map. Everything about the TMDL is based on the water quality standards, on achieving those water quality standards. So I've been asked to include in this discussion things about how the different targets are established for the different clean water service providers. It's important to recall that all of it's about what phosphorus can come into the lake in order to achieve the water quality standards. And I'm going to focus mostly on them rather than the modeling that is followed up to get to those other numbers. The water quality standards were developed by working with lake monitors, volunteer lake monitors that went out regularly during the summer to collect samples. The program itself for the lake monitor started in 1979. They would go out, they would take water samples that were measured for phosphorus, they would see how deep they could see into the water, and for a period of time they were asked to make a subjective, qualitative assessment of the water quality when they took the samples. They rated conditions from 1 to 5, from 1 being the water was perfect, clear, could see everything, to 5 being it was completely not something they wanted to swim in that particular day. The data were collected for 5 years, between 1987 and 1991, And then a mathematical relationship was developed between the correlation between their qualitative assessments of the conditions, that 1 to 5 scale, and the numeric standards that were measured in the water quality samples that they were taken at that time. It was determined based on that mathematical relationship that at 14 micrograms per liter, there was a 95% chance that no algal blooms would be seen. So 14 micrograms per liter was seen as a base standard for good condition. And yet, we see that the standard's not this uniform throughout the lake. There's that range of 10 to 54. So where did that range come from? Well, the couple lake segments, the main lake and Mallett's Bay, the average condition was already better than 14 micrograms per liter. So an arbitrary standard was set near to where the conditions were at the time of 10 micrograms per liter. Then there were other segments where it was determined that that 14 micrograms per liter was not achievable. No matter what was done, that those lake segments would always be higher than that standard. St. Albans Bay was one of those. For that area, they used the average phosphorus concentration at which monitors began to detect poorer conditions. In other words, without that 95% threshold. That was 17 micrograms per liter. For Missisquoi Bay and South Lake A, 25 micrograms per liter was determined to be an appropriate level. Where that number came from, I can't tell you. As far as I know, it was pulled out of a hat. For South Lake B, the standard is 54 micrograms per liter because, according to the 2002 TMDL quote, the non-point source reductions necessary to attain the goal of 25 or 17 would exceed the maximum potential reductions considered possible with best management practices. That quote, if you are with the South Lake BWIC or with the South Lake QUISP, you should memorize that quote because it leads into some of the issues that the South Lake has to deal with. So how are we actually doing with meeting the standards? How far off is Lake Champlain from meeting those standards? Well, Burlington Bay and Cumberland Bay consistently meet the standards. They're usually at or below where they're supposed to be. Isle Lamont, Shelburne Bay, and the South Lake B meet the standards 40 to 50% of the time. Otter Creek, the segment that we work most with, Port Henry, the Northeast Arm, Mallett's Bay, and the main lake meet the standards sometimes, but realistically fewer than 40% of the years. Missisquoi Bay, St. Albans Bay, and South Lake A consistently exceed the standards. In terms of trends, the levels are not changing in most segments. The exceptions are the Northeast Arm, where they're rising, and Missisquoi Bay, where they're falling. So, in summary, the TMDL presents a phosphorus budget for Lake Champlain. Why phosphorus? Because phosphorus is a stand-in for algae blooms because it's thought to be more controllable than the blooms themselves. The TMDL is driven by water quality standards for phosphorus. Those standards were derived from a subjective assessment of conditions, and the standards vary between lake segments. In some cases, the standards are lower because the lake segments already had lower concentrations of phosphorus. In some cases, the standards are higher because the 14 milligrams per liter baseline was considered not achievable. And after 35 years of trying to reduce phosphorus, we see declining trends in only one of 13 lake segments. Thank you for watching. I hope that this presentation provided some new information for you and perhaps raised more questions about the origins of Lake Champlain water quality policy. If you have questions, my contact information is on this slide, and there's also a comment section below the video. If the presentation was useful, please let me know, and let me know if you have interest in other presentations about the Clean Water Service Provider Program.